Okay guys, I'm going to be talking you through one of the practicals that comes up on your biology paper time and time again. Now, we have done a different variation of this practical in lessons. However, I wanted to show you the way that it's set up here because this is the most common setup that comes up on your practical questions, okay? So we're going to be using some pondweed here. We didn't use pondweed, we used ivy. Okay, but this is pondweed. This is my organism that's going to photosynthesize, okay? It's an aquatic organism, which means it needs to be in solution, which is why I have covered it in solution here, okay? So the practical that I'm going to be looking at investigating here is how light intensity affects the rate of photosynthesis. Okay, now the rate of photosynthesis is how quickly photosynthesis is occurring in this organism, and I want to see if the amount of light that it gets is going to affect that. Okay, so my independent variable already is light intensity. Now I'm going to change that in this practical by having a lamp at a set distance from my pondweed. So I'm going to change the distance that my pondweed is from the lamp, okay? So I'm going to have it, say for example, at right here, which is about 2 centimetres from the lamp, turn it on. I'm not going to turn the light on for the purpose of this video because it will just blind you and you won't see anything. But I'm going to turn the light on, leave it to acclimatise for 5 minutes, and then measure how many bubbles are produced in a set amount of time, okay? Because that's what I'm going to be measuring. So my dependent variable here is going to be the rate of photosynthesis, and the way that I'm going to be able to calculate that is by counting the number of bubbles in a set time period. Okay, so from your knowledge of photosynthesis, you should know that you need carbon dioxide and water and light for photosynthesis to happen, and you get glucose and oxygen at the end. So we're going to be measuring the volume of oxygen produced by counting the number of bubbles in here, okay, in a set time period. Now I leave it to acclimatise, okay, and by acclimatise it means that when I change the distance, so if I've got this at 2, I'm going to leave this here with the light on, okay, for 5 minutes. And the reason that I'm going to do that is so that my pondweed here, my photosynthetic organism, can actually get used to the light levels and start photosynthesizing. Because it could be that you're not going to see any bubbles if you start timing it straight away right after you've moved it, okay? The plant needs time to adjust to the levels of light, to adjust its rate of photosynthesis for you to actually see any change. So that's quite important, okay? So we would leave it for 5 minutes to adjust to those conditions, okay? Let's turn the light off for that. Then I would time for a minute, count the number of bubbles and make a record. Now, I said at the start that this needs to be in solution, okay? My control variables for this investigation are the temperature of the room or the temperature of the solution, which is going to be the same. But I'm also going to control the volume of water and the volume of carbon dioxide, which I am going to get from this solution. So this solution is actually sodium hydrogen carbonate, which contains my carbon dioxide, and it's a set concentration. So I know exactly how much carbon dioxide is in here, and I know exactly how much water is in here, okay? So I am controlling the concentration of carbon dioxide and water, but I'm also controlling the volume because I have a standard volume. So I'm currently using 500 centimetres cubed of solution, so that I know exactly how much is in there, so that my carbon dioxide and my water do not become limiting factors. Okay, I don't need those to become limiting factors. I only want to investigate how my light affects the rate of photosynthesis here. Okay, so as I'm going to go through and do my practical, what I should see is that as I move my pondweed further away from the lamp, my rate of photosynthesis is going to decrease. Now, there is a relationship between the distance from the lamp and the light intensity. So when we're calculating light intensity, we calculate it using the formula 1 divided by distance squared. Okay, now the relationship between distance and light intensity is actually something we call inversely proportional. Now, what inversely proportional means is that every time I move my lamp a set distance, my light intensity is going to decrease by half every single time, okay? It's going to increase by the same amount every single time, and it's going to give you a lovely straight line graph, depending on the distances that you're using, okay? The converse to that is proportional relationship, where it increases by the same amount every time, or doubles every single time, okay? That is a mathematical relationship that they might ask you about in your exam question. Okay, so you need to be aware that that happens. So because my light intensity halves every single time I move it away, when I'm up here, I'm probably not even going to see any bubbles in a minute, because I'm getting very little light when it comes here, okay? So that is your investigating photosynthesis practical, okay?